Welcome, everyone. I'm Rachel Green, Digital Communications Specialist here at McNaughton-McKay Electric Company, and I want to welcome you back to our latest Mac and Mac Live series, the Industry Expert Exchange. Each month, a panel of specialists from across our 5 regions cover a new topic, exploring the latest and greatest technology, developments, and challenges in that focus area. We host these live streams once a month on Thursdays at noon Eastern Time, so you can join us on your lunch break. Feel free to ask questions as we go through the session today. There's no need to wait for a Q&A portion at the end, and we will answer those questions in real time. As you join, say hello to us in the comment section. Let us know where you're joining from today. I'll have my eye on those comments as we go along for your questions. Now, if you have questions that we can't get to today, or if you're watching this as a recording, you can always reach out to us at macandmaclive@nc-nc.com. That email address is in the description of this video, and I'll repeat it again at the end of our session. This month's topic is predictive and preventative maintenance. We have a lot to discuss today, so we're going to jump right in. But before we do, let's take a minute to meet our panelists with us today. I'm going to ask you to all introduce yourselves. We'll go around the screen, and if you can give us your name, your area of expertise, and where you're joining us from today. So let's start with Russ.
Thank you. Russ Stone. I'm joining you from Mac and Mac here in Georgia. I'm the services manager for Mac and Mac here. Been with Mac and Mac for 4 years, but prior to that, I've got about 22 years of experience in industry, about 8 years of that as an engineer, 4 or 5 in operations, and then I was a plant manager for the last 10 years. So a lot of manufacturing background leading into this.
Wonderful. Aaron, you want to go next?
Hi, yes, thanks, Rachel. Aaron Brock. I'm services specialist for the coastal region, and I'm joining out of the New Bern office today.
Wonderful. Mike?
Hi, I'm Michael Brennan, joining you from Madison Heights, Michigan, out of our home office headquarters. I've been with McNaughton-McKay 26 years. I'm one of the engineering supervisors for the Automation Systems and Software group with Mac and Mac.
Wonderful. Kevin, you want to go? Oh, Kevin, I believe you're muted. We can't hear you.
Sorry about that.
No worries.
Kevin McDonald, Service and Solutions Specialist for Mac and Mac, Greenville, South Carolina. Been with the company about 8 years.
Wonderful. And Darek.
Very good. Thank you. Good afternoon. My name is Darek Lajiness. I'm a Services Solutions Engineer from McNaughton-McKay in Toledo, Ohio. Been with McNaughton-McKay for 11 years now, and prior to that, I was also in the industry, in the automotive, for about 13 years. So that pretty much sums up my history.
Great. Well, thank you all. You bring a lot of experience to the table for our discussion today, so really great to have you all here. Let's go ahead and jump into our topic today, and we're going to start with a really broad question that I'll direct to Mike. What is predictive and preventative maintenance?
Hey, Rachel, thanks for asking the question. It's a great question. So we'll talk about predictive and preventative maintenance, but there's a couple other types of maintenance I wanted to bring up as well. One of those is run to failure and breakdown maintenance. So what we're seeing is predictive and preventative are hot topics today, but some of the customers that we've talked to, they're stuck in what we'll call run to failure or breakdown maintenance. And I want to bring those topics up just to kind of set the level set. So run to failure, the best way to think about that is think about a light bulb, right? So we're not actively walking around changing light bulbs, right? What do? We turn the light bulb on and we wait till it fails and then we change it, right? So some applications, from a cost perspective, it makes sense to do run to failure. Now, if it's a heavy piece of equipment where downtime's a big issue, run to failure is probably not the best solution. And that's why we're having this discussion today. Another concept that we've seen customers in is something we'll call breakdown maintenance. And what does that mean? So that's a customer who's not thinking about predictive, they're not thinking about preventative maintenance. Basically, they're running their machine, and when it breaks down, they just do whatever they can to fix it, right? So those two situations, while you're not paying for maintenance programs, you're not paying for folks to walk around and do some of the things we'll talk about in a little bit, they can be very expensive when you have a breakdown condition. So then let's get into predictive and preventative, right? So there are 2 different types of maintenance in that sense. So when we think of preventative maintenance, what we're doing is that's a program that's put in place, and we're starting to understand the components that we have in the system and traditional failures that we see, and we're developing a plan and going around and performing maintenance on a set schedule, right? So if you think about mechanical failure, right, we're going around, we're greasing bearings, we're doing the types of things that we need to do in that sense. The cool thing is predictive maintenance, right? And that's what we'll talk a little bit about today, but predictive maintenance is using things like sensors and tools that we have, right, to determine when failure is going to occur ahead of time, right? So what we're trying to do is get out in front of that so that we can get into that scheduled maintenance pass a piece. So we'll talk, that's kind of an important topic, right? So when we talked about breakdown, when we talked about run to failure, right, typically those create unscheduled downtime conditions. And that's what everybody's trying to prevent, because unscheduled downtime is very expensive, right? So if we can do that predictive and preventative maintenance, that gets us into that scheduled downtime piece, right? And we're not having employees that we have to send home, right? We're not trying to bring additional maintenance staff or potentially contractors in, right, to do work at a very expensive emergency rate. So there's a lot of costs added to not doing predictive or preventative maintenance.
Yeah.
Yeah, so we see, customers, either you're going to be a reactive type of customer or a proactive type of customer. So your run to failure is your reactive type. And those are the ones that are always in chaos, always firefighting, always chasing. And really where we're trying to migrate to, and most people are, is to be more of that proactive customer. So as we're talking here, preventive maintenance is doing the task monthly, daily, quarterly, changing the oil, greasing the bearings, changing the filters. Think about your car, right? You're not going to run your car until it runs out of oil. You're hopefully going to take care of it. So that's the preventive stuff that should have a regular cadence. The predictive side, though, is using more of the tools and the analytics and the trending and the history so that we can try to analyze through sensors or whatever mechanism there is when we believe that product is going to fail, when it's going to become unsafe. So now we can correct the issue before the issue corrects you.
Great. Yeah. Well,
I found too. Oh, go ahead.
No, go ahead, Darek.
I was going to say, I found too that a lot of companies, will say, well, I'm restricted by my budget. I can only do so much. However, I think the most effective thing would be to prioritize your assets. So your assets, whether, it's $100,000 to replace, a medium voltage drive or whatever the case may be, I would focus more towards maintaining those types of products that are actually going to be your highest cost versus items that are consumable, easily replaceable, easy to get. Because as I spoke about the drive being an example, it's typically a longer lead time to get the product. If you don't have a very good budget, then most likely you may not have the spare product on the shelf readily available to be able to install right away if that became, the issue. And then you're reaching out to, McNaughton-McKay or some other vendors saying, I need this immediately, and it's just not something that's held in stock due to the high cost and value of that asset. So I found typically that happens, but yeah, go ahead.
Yeah, from a plant P&L perspective, from a pure financial perspective, it is so much more economical to fix it on your terms versus fix it on the equipment's terms. Sending people home, paying the overhead costs, paying the premium freight, it's tenfold if you just take care of it and fix it when you need to and be proactive.
Yeah, they always they do make the comments about budget constraints, but whenever there's a downtime event, the money always seems to be found some way. So I think maybe a little bit better planning, right, to make this possible.
Well, and it's amazing how much more you budget for repair and maintenance than you budget for capital expense too, for that very reason.
That's a good point.
This actually leads us into our next question, which I'll direct to Kevin actually, which is, what are some of the main challenges when developing a maintenance plan in a facility?
One of the first ones I'd like to talk about is resource constraints. The last 20 years, plants have been motivated to lean their staff and lean expenses and a bit more efficient processes and stuff. And this can lead to people being reactive because they just don't have enough time to keep up. And this reactive cycle, it's a snowball. You start getting reactive, you don't have time to do anything proactive, no maintenance. It gets worse and worse and worse, and you get more and more reactive. Somehow you got to break that cycle and start your proactive, and then you actually reverse and go the opposite way. The more you're proactive, the less you're reactive, and then everybody's happy, and the costs go way down again when you proactively schedule downtime and maintenance versus respond to repairs and accidents. The next one is the skills gap. They say by 2025, 2.7 million baby boomers will retire. This is going to take away a lot of knowledge and a lot of experience. That's going to, how do we bring the new people up to speed? You can never replace experience. So you can just give them knowledge and let them go out and earn that experience. That leads to training. Training is another issue, especially with the lean resources. Do you have the time? Do you have the cost? Do you have, can you afford not to send somebody to training or give them the training they need? Another issue we're having, I don't think I have to say this too loud, supply chain issues. I've been in manufacturing for now almost 30 years, and I've never seen anything. This is just crazy. And so one of the things that people might need to consider is to be proactive and increase your limits on what you do have in the storeroom. That way you prevent those excessive costs that you all were just talking about. Other issues is budget. Again, that goes with being lean. Budgets are lean. So everybody's trying to be profitable, but a lot of these stuff lead to reactive cycles versus proactive.
Absolutely.
Yeah, I'm sorry.
I was just going to say anytime in advance. Yeah, go ahead.
Completely agree with, that supply chain right now is a major issue for a lot of customers, everyone, right? No matter where you are, industrial, food and bev, wherever. So, preventative and proactive, maintenance is something that you can plan for, right? Like we kind of talked about earlier, you can get those resources in place ahead of time. So you've got them there to take care of the situation before it arises, right? Whether it is labor or hardware, it's just that point right now is a major issue, and it should kind of have people thinking more about these types of topics.
Yeah, you touched on lean, and I think of lean through a couple of lenses, and obviously the lean we're talking about here is resource constraints. Factories are getting smaller. You don't have the personnel that you had 20 years ago because of cost constraints and therefore the skills gaps. I view lean though more of lean from a traditional Six Sigma approach of continuous improvement, and you're trying to continuously get better. You lean out the people, you figure out what to outsource or outsource and what you can do well. But at the end of the day, to me, it comes down to the value added activity and the non-value activity that you do. And you want your people at your facility doing value added activity. And some of the stuff that we're talking about doing that the plants would outsource, we come in, do it for you, whether it's a Mac or a Rockwell or a whomever. Those are non-value activities to you, but they are very valuable to you. So it's much better suited to have the professional come in to do it, to do the analytics, to give you the data, to give you the guidance. So your value activity as a plant is making the corrections and keeping your processes running.
Absolutely. I would also think that in today's day and age, the importance of actually planning and looking way further in advance just to prepare for what you may need or work with your local vendors, to be able to maybe have that product set aside or held for you. And right now it's not as convenient. Maybe you're having to repair your devices versus getting brand new product. Being able to you know, work with your local vendor, like I said, just to be able to maybe do a consignment type thing or anything that can help stay within that budget, that lean process, and then be able to, you know, have the product readily available.
Yeah, and it's important too, as we have conversations, you know, a lot of times we say we don't want to get beyond our skis. We want to just focus on what's going on today. And that's where plants get stuck is, I got to get through the day. I've got to make production today. I've got to get through the week. I've got demands. And it's again, your firefighting mode. But what we're trying to shift to from a proactive mindset is more of that strategic planning, you know, and talking about not what's going on today or this week, but what are we going to be doing this coming year? What's a 2-year plan? What's a 3-year plan? What's a 5-year plan? From predictive maintenance to preventive maintenance to spares to migration policies, whatever it is. Let's think farther out and be more strategic in our mindset versus I just got to get through the day.
Yeah, and two, you know, the strategic planning, it plays into the budgeting, you know, as well. So if you're working with your, you know, whether it's Mac or not, your local partners, we can put together plans and service agreements and different types of things to stretch out those costs over 12 months or multiple years, right? So that's another way to look at it for budgeting to help assist with those costs.
It's a great point.
Thinking about, you know, how to get started and, you know, developing a plan like this, this question would be for Mike. How do you determine which assets and which pieces of equipment need preventative maintenance?
Yeah, so there's a couple different ways that I like to think about it, right? So one of the things we're having discussion with folks, especially if we're looking at the predictive side, we'll talk about that in just a sec, but if we're looking at from a pure risk perspective, right, one of the things that we've been doing quite a bit of up in the north, what we call the northern region for Mac is install-based evaluation, right? And what that means is basically coming in and doing an inventory of the components that you have, right, and trying to determine from a risk perspective those components, right? What's legacy, what's obsolete, right? While we're doing that, one of the things we'll want to do is characterize those types of machines with our customer and say, okay, what's mission critical for you? What's required for you to run this individual plant and or facility, right? So if it's an RTO or something like that, that's an environmental perspective where if I've got a fan and if that fan's not running, I can't run my facility. Well, I'm gonna want to be a little bit more thorough in terms of a maintenance plan associated with those equipments. I'm going to want to look at that IBE and see what risk is required there and maybe use that to determine what's my plan for maintenance associated with it and potentially what's my plan for modernization or capital improvement.
Very good.
Yeah.
And utilizing those plans, you know, for, you know, modernization as an example, you know, when we go in and replace older machinery with newer machinery, you know, sometimes it can be less expensive to maintain, right? And have less steps or less complicated as far as maintaining individual items. So it all just plays together.
A lot of the newer products are actually cheaper than the older products. You find that you can replace an entire PLC for the cost of an old processor alone. So then this becomes, when planned, becomes a very cost-effective budget strategy.
Yeah, and it ties back to the earlier comment. You know, that's why most facilities, your repair and maintenance budget is so much higher than your capital budget because your cost to maintain older stuff is so much more expensive and inefficient than making the right steps up front, being proactive.
Yeah, and the IBE as well will help you understand what types of spare inventories you need in your plant, right? So if you're spending too much money on spares that you don't need, that's money you could spend other places for additional maintenance costs and labor costs and everything else. Training, right? It seems to be one of the hardest things, you know, sometimes is to get budget money for training. It seems to be the last place people seem to invest a lot of times. So if you can help a customer understand, you know, where they can utilize their money the best and utilize their resources, you can help them find those dollars a lot of times.
Absolutely. Even
one of the things Oh, go ahead, Derek. Sorry.
Oh, I was just going to say thank you. I was just going to say, even if it's online training or something less expensive where you don't have to travel, you're not out of the office for a week, you can do it more on an hour or two basis versus being out of the office for a 4-day class or something. So.
Yeah, Derek, you hit the same topic I was going to talk about, right? We have seen an evolution, right, where more and more training is available online, right, from all different kinds of vendors, right? I mean, when you look at what McNaughton-McKay's done over the last year in terms of information that's available on our YouTube site, right, that we have all different kinds of topics, all different kinds of products, a lot of it relating to modernization and some of the things that we've talked about, right? So more and more folks are expecting information to be available online, right? And training classes available to be done online as well. So I'm glad that we've seen that kind of modernize a little bit, that online training piece.
Yeah, I completely agree. Having those conversations with the customers, specifically about training and online training, you get people do like to train different ways, right? We're all kind of have our own way we learn the best. But with online training, one of the larger concerns that I would run into is they just don't have anybody to interact with, right? So one of the great things, that with the online training through the Rockwell e-learning and Learning Plus platform is you do have the option to log into those virtual classroom events that coincide specifically with the training class you're taking. So you've got that live exchange with an instructor that you can ask those questions that maybe this didn't make sense, or just reinforce the lesson plan that you're working through on a module base, but have that little bit of taste of in-person training as well. So that's really one of the greatest things I think they've done so far in modernizing the online platform.
Very good.
Great. Yeah. Well, kind of going back to what you guys were talking about with older machinery, newer machinery, bringing new things in. This one's for Darek. How can users better understand the life cycle of different equipment that they may have?
Yeah, so manufacturers typically, have a mean time to failure for their products. They do know what to expect as for, you're going to get 10 to 15 years out of this product. But if you want to be able to, make sure you get to those 10 to 15 years of life, you're going to want to do the preventative and predictive maintenance in order to do that. Otherwise, you're going to get 5, 8 years maybe out of the product. And like I said, it varies by product and which can, definitely be a concern otherwise. I know with like Rockwell Automation, they have a life cycle page. You're able to enter a product name or part number, and either the name or number, you'll be able to get a whole list of whether the product is active, meaning that it's the most current product that's being manufactured. Active, mature, just means that there's something that's newer than it, but it's still very active product in the workforce being utilized. Then they have end of life, which is 6 to 18 months before it's going to be discontinued. And then products do have to be discontinued to continue down the growth and expansion of keeping up with the industry, and those type of things. So it is very important, I guess, just to look and work with your manufacturer or your supplier like McNaughton-McKay in order to get that information, what the life cycle is to expect, whether it's repairable or it's not, and be able to increase the longevity of the product and I guess avoid that unplanned downtime, which can be very expensive.
Yeah, and Derek, that's another one of the benefits of that IBE, right? Is if I was a plant manager and I looked at my facility and it had aging components and new components, and I was trying to figure out how to determine where I was at in that life cycle, right? That would seem like a daunting task to me, right? That's really one of the major benefits that we see from that IBE is being able to see where you're at on that life cycle.
Yeah, and every one of these we do. Typically customers want to do them because they need spares, because they can't get spares due to supply chain, and that's an easy discussion to have. and it's easy to pinpoint what spares they need. But what's really daunting and when you're trying to analyze risk at a leadership level, you want to know what you're at risk at in your plant. And when you see all the code red items on that report that these are obsolete parts that are on critical assets running in your facility that you don't have a spare for, if this goes down, you're down. You're on eBay shopping, you're trying to patch it up with super glue and duct tape, you have an issue. So from a risk mitigation standpoint, that is very critical.
Yeah.
Very well put.
Yeah. It's interesting to have those IBE readouts with your customer and hear the feedback, right? So sometimes they see all the red. Well, I didn't realize chopping had. Wow, I thought maybe it was palletizing or curing or somewhere. It's just interesting to hear that feedback, and you can see the value coming alive right in front of the customer. So it's kind of fun, but it's interesting.
True.
Yeah, you can't rely anymore on Jim the electrician having the spare PLC under his desk, right?
No, and those again lead right into those strategic plans, because and the customer knows you can't do it all at once, but let's prioritize the risk, let's prioritize criticality of assets. Where do we start? And let's develop a 3-year plan to do it, along with that 3-year plan to maintain what we have and keep it from failing.
Yeah, one of the cool things that we've seen with a couple of customers, let's say they're a customer that had, a bunch of PLC5s in their system. As we convert assets, we're also developing spares for their other pieces of equipment. And that's something that helps with that cost from that, from that perspective of being able to have a 3-year or 5-year plan, because now I've got assets, potentially more important assets that are migrated, but then my existing assets, now I've got spares for those. So that's an interesting thing to think about.
And making, I guess, your standard, let's just say I mentioned Rockwell Automation. So kind of making your standard for if you're getting new product in, like a new machine, for example, from an OEM, delivering that machine. So you'll probably already, if you stay with that same manufacturer, you're already going to have other spares and equipment in the plant that most likely can support line 3, 4, and 5 versus getting different types of manufacturers and not having a uniform install base, and come to find out, you're trying to work with too many suppliers to get the products you need. And especially now in this particular time, it's best to be more concise.
Yeah, you'll hear you'll sometimes see customers and help them understand that they're actually stocking the same part under different part numbers because they have multiple suppliers, right? So something they weren't aware of at the time, and again, just making their supplies more efficient for them, their safety stock, and just more benefit there.
You bring up a really good point, right? So, in some of the users that we have up in our area, one of the things that we've been trying to do is crib consolidations with them, right? So going into the crib, and especially things like sensors, cord sets, Ethernet cords, fittings, those types of things, right? Is saying, okay, if we can consolidate, an 18mm prox that you have 4 different vendors of down to one part number, right?
Mm-hmm.
That we can readily get, right? There's a ton of value there. So that's something that we've been doing quite a bit of over the years, and then developing a guide for them so they can, very quickly convert that to the product that we put in spares, and even manage that inventory level for them, right? So that's a huge piece, I think, from a maintenance perspective, knowing that you're going to go in there, that somebody's going to manage the inventory level of that 18mm your prox that you need, right? So
Absolutely.
yeah.
Well, I'll move on to our next question then. This one is actually for Aaron. How often should assets be maintained, and what are some of the tools used to establish a schedule?
Yeah, so generally with most products you'll purchase or bring into your facility, the original equipment manufacturer will provide some sort of a guideline and a schedule to maintain, not only as far as like an annual schedule, but over the life cycle of the product. A lot of times they'll give you, at 5 years, you should do this, at 10 years, So that's really where most people should be reaching out to get that type of information from. They're going to get the most accurate information to best service their equipment. Maintaining that type of information and creating those planning schedules to do the preventative maintenance for these types of scenarios, you need some sort of a CMMS system. That's what they're designed for. And that's where it will store all the information for the different procedures that you need to do. Rockwell has just actually launched last year, I think it was, the Fiix platform, which is it's an interesting CMMS system. I've had some experience with it. It's very user friendly. A lot of things people use nowadays have specific touch and feel to them. The user interfaces are very simple. They're carried around on mobile platforms. And with the Fiix platform, you do have a mobile app that you can use for the different individuals out in the field. So if you go in and assign, a work order to John, if he's got the app on his phone or his device or tablet, whatever he's using in the field, that work order will pop up. It'll have a description of the event that needs to occur, the line item list of how to do that, how to complete it, the parts list you need to complete it. Also, when you go in and manage the work orders for different types of events, making sure you have the right stock, in your facility is crucial. So if you can have it directly tied to your inventory management system, whether it's the same system or not, and it can give notifications to the storeroom if it sees that we have an event coming up, we're going to need these specific parts. Looks like we may have low inventory. So it's a great platform, something that I encourage a lot of people to take a look at. There's a lot of links to it either on the Mac and Mac website or on the Rockwell website if you prefer, or just Google, Fiix, F-I-I-X. It's really interesting and something I think will catch on, eventually.
I can actually add that link after we conclude today. I'll add the Fiix link to this video description for anyone that's interested.
Yeah, reach out to your local office, ask them about it. They'll get you in touch with someone that can kind of go over it or demo it for you. It's really neat tool. It's not clunky like some of the older systems that you've seen around for years and years and years. It's new, it's modern, it's fresh, and it's really useful. So give it a look.
Talking about CMMS, that's a term maybe some of us are not familiar with. Can you guys talk to us about what CMMS is just real quick?
Yeah, it's a computerized maintenance system, right? So it's helps, like I said before, it helps people maintain those records, keep track of events that need to occur, and throughout the life cycle of their different products. So
Yeah, it connects assets, so like assets that the customer owns to people, right? So if you have people that do maintenance for specific things, right? It says, okay, this is my asset. Here's the things that need to be maintained. Here's the schedule and/or procedures that need to be done, and let me tie those things to the right people, and then assign them those specific tasks on a continuing rate, right? So again, it's in that preventative maintenance piece. Now, could it be predictive? Yeah, it really could. You could take things like sensors, tie them into the CMMS, and then trigger work orders to be done to fix a certain thing. So if we talked about like a proc switch, right? A lot of times in our area, proc switches, are part presence. People stick parts in, shears the head off of procs. Oh, now the procs is bad, right? You could have the PLC then issue that work order saying, hey, go fix the procs that's on this tool, and it's this procs, and you need this part number, right? So that CMMS tool, that's the whole goal behind that, is to be able to say, okay, I'm going to develop my plan, have it do my preventative maintenance, right? But also allow me to be predictive, right? If I tie the right pieces and parts into that system. So
it's definitely a step forward, the way they're moving with integrating into the predictive environment, right? Instead of, just a spreadsheet with Jimmy on Thursday is going to go lube this bearing, right? So we're progressing forward to be able to better plan these types of things and just modernize our process, right? Not just our equipment, we need to modernize our processes.
Yeah,
So just
and
forward
I
thinking.
view it as kind of moving away from tribal knowledge. Tribal knowledge is, like you said, Jimmy goes on Thursdays and he does this, right? Well, what happens when Jimmy's out on vacation? Well, that doesn't get done because that's what Jimmy did. And Jimmy does it this way on third, but John does it this way on first. So it's taking those processes, developing standard and best practices to those processes. It's automating those. It's tying the assets to the people, to the job task, developing it within the required cadence that you need, whether it's from a purely preventive mode or whether it's tied through some data analytics in a predictive mode. But it's all centered around a standard process for that person to take care of that asset to keep it running and reliable.
Perfect.
Great. Well, getting into some of maybe the predictive side of this, Russ, can we talk a little bit about thermography, ultrasonics? Why does a user need it? What is it?
Sure. So we've been very specific, talking about machine specific. So we'll back it up and we'll talk at about 40,000 feet. So to me, from a preventive and predictive mindset, and a lot of people use those terms synonymously, so it doesn't matter, but we'll call it PM, right? From a PM standpoint, to me, the three major legs of PM is thermography, ultrasonics, and vibration analysis. And we do those holistically throughout an organization or throughout a factory. It's not specific to a piece of equipment, it's agnostic, it's everywhere. And you do those things to be preventive, to be predictive, to make sure that you're not going to be reactive. So take thermography, for example. We're going to go out with a thermal camera, we're going to open up electrical panels down to a contact block on a PLC if you want, but we're going to be looking for temperature variations within equipment, within machines, within components to try to find some abnormality, right? So we're being predictive. We're trying to understand what the normal running state is so that now we can go and define or go locate those abnormalities or those unnatural running states. Then we can prioritize those mission critical. This is running at 300 degrees and it should be running at 75 degrees. It's going to be a fire hazard within a day. It's going to shut you down when you don't want it to. Fix this, 911 versus this has a 30-degree temperature delta, so it needs to be addressed over 6 months. So those are good tools to help you understand heat loads, understand critical assets, understand risk. And all these things, we sell tools, we sell FLIR tools and Fluke tools, and everybody can go buy thermal cameras and do it themselves. But that kind of goes back to the whole resource allocation model. What's the value added thing you want to do at your plant versus the non-value added thing? You can train people to do it, but if you train somebody to do it and they do it once a year, they're not going to be efficient at it. So make sure you have us, make sure you have the professional, someone that's certified at that level that does this all the time, that not only knows what to look at, but knows how to do the analysis and give great line of sight, click, this is what you need to go do to fix your issue. So we're looking at it, we're trying to find abnormalities in the system, we're trying to be predictive and tell you based on an abnormality, it's a 911 fix, or just get to it over the next 6 months when you do your PM cycle. So that's thermography, and that's one of the keys. Ultrasonics, we're looking for air leaks. You've got compressors, every plant, everywhere has got air compressors. So when we're talking about ultrasonics, we're looking for those air leaks, and the air leaks is where your compressor is running, consuming energy, pumping air to run equipment, and that air is going into the atmosphere. So you are just wasting money, right? So sustainability is key. Energy conservation is key. Obviously, for most of these facilities, the ROI, the payback of what we do for an ultrasonic study to what you get in return is 5 times, 10 times just in a year's period. So you do those for sustainability purposes, for energy reduction. And then the third one is vibration, and that is purely predictive. You do that quarterly, you do that semi-annually. You're checking bearings, you're checking races, you're checking belts. You're looking for harmonics, again, like with thermography. You want to understand what your baseline is, understand what normal operating mode is, build that history so that when you start to see these abnormalities creep in, you can understand, hey, this is going to fail in a month or a day or in a year. So you can be predictive. And again, It is so much more cost effective to fix it when you want to fix it versus fix it when it tells you to be fixed.
Mhm.
You touched a little bit on some of the benefits of outsourcing this as well. Do you want to talk a little bit more about that and why facilities might want to bring someone like us in to do that for them?
Yeah, absolutely. And again, a lot of the stuff, some things facilities can do. You can buy an ultrasonic tool and you can give somebody headphones and they can do it. But now you're going to have a resource that you're paying most of the time to be at a facility to do it. Same thing with a thermography camera. So you can buy the tools, facilities can buy the tools and do it themselves. But again, it's much better to have a trained expert that knows what they're looking at, that can give you a professional report, line of sight on what to go fix. Let us do the non-value added work for you so that you can focus on the corrections, which should be your value added work. Vibration analysis is a different animal. You need an expert, just like with an arc flash study. You can't train somebody to do that. You need an engineering firm, engineering professionals, folks like us with resources that can go out and do it and do the true analytics in the background to tell you what to do. And really, we're just talking about those point of sight, show up on a quarterly basis, do it. And there's a whole nother animal of continuous vibration monitoring for continuously watching equipment that are key critical equipment that you need to know, is it running good at 8 a.m. and then is it running good at 10 a.m.? So there's another animal. But in a nutshell, anybody can do a lot of this stuff, but it's much more valuable to a customer to have an expert do it for you. It's also good to buy the tools and have the tools at a customer so that now if we come in once a year and do it, or if we come in once a quarter to do it, we can still train you on how to do it. You're not going to be proficient. You're not going to be the expert. But as you have an issue start to show up in a machine, you do have a tool at hand where I can go do a spot check. Let me go see if this feels warm. Let me go see what this is.
Yeah, to add to that, we kind of already covered the limited resources within the facility, right? So they may not have someone that they can dedicate to, walk around weekly, quarterly, semi-annually to do these type of things. So again, just another way to utilize, your business partners to help you take those tasks on.
Yeah, one of the things we've been doing as part of the IBE is tying up like a baseline thermography into that, right? Because as part of the IBE, we've got to open every single panel anyway. So why not, if we're in there, why not build thermography into that? And it's worked out really well because it's a report that we can provide to the customer. We're in documenting what's in their panels anyway. So it's just a natural progression.
Yeah, and we do the same. We do it for IBEs. We do it when we're doing arc flash studies because you're in the bigger breakers doing arc flash studies. One of the big benefits, because it's very cost effective to have us do it. It's really not expensive at the end of the day, especially compared to a downtime event. But we have a lot of clients that want us in there every month or every other month. And so we'll pick 2 days a month and we'll come in and we'll do vibration analysis on these 2 machines. We'll do thermography on those 2 machines. We'll do ultrasonics on those 2 machines. They'll get the reports, and then they can use that as their analytics over the next 3 months to go and make their corrections. The next month, we'll do this machine and do the same analytics. And then eventually we get back within a period of time to the ones we did already. And now we can go validate the results of whatever changes that they made. So it's not necessarily go change your oil once a year and hope that it doesn't run out over that year. It's a lean process. It's continuous improvement. Every time you find one issue today, well, guess what? Another issue is going to come up tomorrow. So the better your cadence is of staying ahead of it, the better analytics you have to know what to do. And then to have a part that can come in and validate that what you did worked and fixed it, the more your uptime is going to go. And we all know for a manufacturing plant, when you're running, you're making money. When you're not running, you're losing money, right?
Well put.
Talking about vibration analysis, you mentioned, that's a whole other animal. This question is from Mike, and we did touch on this a little bit, but what types of vibration analysis are available out there?
Yeah, so we do the walk around, the semi-annual walk around vibration analysis, but one of the things that we're seeing as a trend, and there's a couple different vendors that we work with today, but that continuous vibration monitoring, right? So that's putting, single axis, multi-axis vibration sensors in specific locations on motors and bearings and gearboxes, right? And then doing an analysis of that. Now, some of it is just your simple check engine light, right? So there's a certain threshold. We know what a typical vibration signature is going to look like. If we exceed that signature, we're gonna send a warning out, right? We're gonna then say, hey, something's going on here. Now that's again that we're getting into that predictive maintenance piece, but that's why we talked so much a little bit ago about identifying what your critical assets are, right? So if you have to have that blower motor, if you have to have that vacuum pump, if that's got to run or your plant can't run, those are the types of machines that you're going to want to do vibration analysis continually on. So you can then say, okay, I'm going to start with this check engine light, and then I'm going to move to the next piece of it, which we talked a little bit about, and that's getting into harmonics on that vibration signature, so I can determine where those issues are, and then potentially go and fix those issues, right? So
think about an air compressor. An air compressor, everything in your facility runs on air. So if air compressor goes down, everything's down.
Yeah, that's a really good point. To that point, we talked a little bit about vibrations from an analysis perspective, but one of the things that we're seeing is in a trend, and again, it's a little bit automotive centric, but there's a lot of conveyance in automotive, right? And downtime in an automotive facility is about $25,000 a minute that we hear from a downtime perspective. So that's significant, right? So one of the things that we're trying to do is say, okay, if we're selling armor starts and drives into conveyance systems, and some of these conveyance systems, you think of lifts, vertical lifts, right, where they move vehicles from one level to the next level. If I don't have that lift, there's not a really good way for me to move that car from the floor level, let's say, to the 15-foot level. I've got to have that to run my facility. So one of the things that we're doing, there's a sample code that's available called the Analytics Toolbox. So what that is a simple code that goes into your PLC, simple HMI screens, and we can do an analysis over time of a process. So we can watch things like voltage, we can watch things like current, right? And we can determine, hey, is the voltage changing? Is the current changing, right? What's going on with my process over time? So we'll develop this concept of a golden signature and say, okay, this is what when we see this golden signature, we know that the machine's operating as it should. If it goes outside of those boundaries, for example, if we're monitoring also acceleration, right? If we see changes in acceleration, then we know something potentially mechanically could be going wrong, right? So if we can have that essentially free of charge, it's a toolbox that you can download. Now, Mac, we can come out, we can actually implement those analytics for you on your piece of conveyance, but that's a piece that you could then monitor that vertical lift, and if you see an issue, let's say with current, or you see an issue with time, even cycle time for that, that on my next scheduled downtime event, I've got to go in and diagnose what that potential issue is. So we're seeing folks start to transition to that. Now, the goal would be then if you choose the McNaughton-McKay solution from a drives perspective, right, and you want to use it with Allen Bradley products, well, this is a natural outcome of that, right? There's analytics and predictive analytics that come from just utilizing our product, and that's where we're going, meaning McNaughton-McKay. From that perspective, is being able to provide that. So that's kind of a unique piece that we're seeing.
That brings us actually to our last topic, which is those predictive analytics that you're talking about. Again, a question for Mike here. What types of facilities would benefit from predictive analytics?
So really any facility that has mission critical assets, right? That if those mission critical assets are not running, then they can't make whatever it is that they need to make to make money, right? So, and that's really what we when we talk to folks, we go to that prioritization, right? What are those most critical assets? You don't need to monitor every single asset in your facility, right? That doesn't make any sense from a financial perspective. If you focus on those mission critical assets, right, and you can determine and and be able to understand when you're going to see that failure, right? Then you're not going to be caught in that downtime situation, right? You're not going to be paying those extra overcharges for, flying people and assets and components in. You're not going to be doing that, right? So that's really important, right? That's what we're seeing as a trend is folks are saying, hey, listen, if I'm going to invest anything, I'm going to choose to do it in, that great example of an air compressor, right? I've got to have air to run my facility. If I don't have air, I don't have anything. So, yeah.
And
Oh, go ahead.
I was just going to say, I've noticed in the past too, as we, monitor products or different things like that, it sometimes, I guess, provides a better understanding of what other things outside of the process could be causing the failure, or I guess shortening the length of the life cycle of the product, such as energy, like incoming power from the power company during the summer months in an industrial park that most manufacturing companies are really utilizing the energy, whether it's air conditioning or all the above. We see that the electric company puts out more power at that time of year in order to make sure everybody has enough energy to process, and that can really affect your equipment or the sensitivity of I guess circuit breakers tripping or different things like that, overloads and things. So you can, by just ignoring everything and only repairing when products fail, you're going to miss those key things that could be detrimental to your process and give you increased downtime.
Which you got to have good incoming power quality. Absolutely.
Yeah, and working with the same partner, especially if you have multiple facilities, you'll start to identify where there's facility-specific issues, right? So we work with, for example, multiple facilities for specific automotive customers. And what we find is, right, we'll have products that we install in 9 of 10 of their facilities have no issues, but 1 out of 10 of those facilities, right, will have nothing but failures. And always that relates to power.
Yeah, and some facilities may have their own supplemental power sources, right? So generators. So the interplay between the incoming from the utility versus that, can cause issues as well.
Yeah.
Well, our last question here is, where can users get started with predictive analytics? Where do viewers watching this start with implementing something like that?
Yeah, and I think the key is talk to your McNaughton-McKay team, right? I talked a little bit about the Analytics Toolbox that Rockwell offers. That's on their sample code website. But there's a lot of different solutions that we can offer. Some of it simple, right? Some of it a little bit more complex. But if you're really looking at getting started with that predictive analytics piece, right, we can even get to that check engine light piece very quickly, right? To where we look and monitor and look at your piece of equipment and then determine, hey, this is where that signature should be, right? If it exceeds that, we're going to send a warning to folks, and you can go in and take a look at, where those issues occur. So talk to your local McNaughton-McKay team for that.
Great. Well, we are just about out of time, so we'll go ahead and wrap it up here. If you have questions, or if you're watching this as a recording, you can always reach out to us at the McNaughton-McKay Live email address. That email address is in the description down below, McNaughton-McKay@nc-nc.com. I will be also adding the Fiix website in this description as well if you are interested in learning more about Fiix's CMMS system. So I want to say thank you to all of our panelists here today. Mike, Russ, Kevin, Aaron, Darek, you've given us a lot of great insights here. This has been a wonderful discussion. And a big thank you to everyone watching us live. We hope this session was informative and engaging for you. If you haven't already, please subscribe to the McNaughton-McKay YouTube channel for more industry content like this. And we hope to see you live again next month. Thank you, everyone. Have a great day.
Thank you.
Thank you.
Thank you.
Thank you.